Hello and welcome to my video where I will show you how I restored the shock absorber of my Tomos moped motorcycle. I will start off by removing the rubber damper with the steel bushing using the small tool that I 3D printed. Interestingly, a Tomos manual states that these shock absorbers are not serviceable, and then when failing they should be replaced. But unfortunately the items that you can find these days, whether Chinese or Italian, are completely different looking ones, not even close to this original. The rubber itself should go fairly easy by hand or by using a screwdriver handle. Next step is actually to unscrew the upper part from the lower one, and for this reason again I 3D printed a small tool. Now comes the fun part. Most units that I've disassembled were completely dried, meaning that for sure the damage occurred. This also means that the stem guide is hugely worn and that the steel washer at the end made some or huge damage to the cylinder below. W40 or some penetration oil would definitely help here. Here it is. Since it's all dried out, corrosion made its work. And here is this stem guide, which is now, if you can see, hugely worn, which makes the stem wobble, and a steel washer at the bottom scratching the surface of a cylinder. The spring itself, although looking bad, might not be that bad at the end. After all, we will clean it up, remove the corrosion, and we'll see. These are all the parts laid out to be cleaned, degreased, and stripped of corrosion. First is to degrease them. It's a simple, mild solution of detergent and some solvents. Next comes corrosion removal. For this I'm using a commercial product. Contains, I think, phosphoric acid, which is the main active ingredient. You should be very careful with this. I usually leave it overnight. This product doesn't do any damage as far as I saw to any base material. It really only removes the oxides. Once corrosion has been removed, I think it's safe to remove this rubber damper without damaging its surface. After the corrosion removal, the stem for sure doesn't look that nice. So what we will do is we will polish it using abrasive paper, starting from granulation 800 up to a 2000 and finishing with polishing paste. What I expect is to see pitting, strong corrosion pitting, which in case of regular shock absorbers for bigger motorcycles, for cars, would cause problems because it could damage the oil seals, the lips of oil seals. However, if you saw in this case, we don't have such a construction. It's a simple shock absorber with only this guide, so there is nothing to damage with those pits, with those holes. In fact, it might even serve as some oil pockets. Next we will clean the thread. It's a simple M8, a standard M8 times 1.25 I think thread. Paint stripping will be done by using paint stripper. It's an alkali based solution. I will use aluminum foil to wrap it up and to have better effect. I will leave it overnight. So next day, when paint stripper has done its job, I will use a simple brush to remove the paint mechanically. A brass brush is preferred here in order not to damage the aluminum surface. before the sandblasting process, I still would like to remove small marks, casting lines, whatever, to clean it up further. Unfortunately, the stem guide was so badly worn that it wobbled so much that a washer, a steel washer at the end, made huge damage on its cylinder. But I will still use it since I do not have at the moment better one, yeah. I will mask the sensitive surfaces before the sandblasting in order not to damage them. I will not be showing the sandblasting process as I cannot put a camera inside the box, but I can show you my box. It's a simple setup of a box that can be bought with rubber gloves and a cheap sandblasting gun. This is now sandblasting done. You can see the finished sandblasted items. I took the opportunity also to sandblast the other parts that will go into same color, including this throttle grip, but unfortunately after the sandblasting process I noticed this serious cracks, so I won't be using it at the end. I won't go into details regarding painting, just to say that it's a 2K system from Lechler, 2K epoxy primer as a starting point, then a base coat, and at the end matte clear coat from Mobihel. Springs will only have 2K epoxy primer, as they will not be exposed to outside conditions, UV light mostly. Unfortunately, the base coat is too light, so at the end I have decided to other shade. I will show it next. The stem guide, as I already shown, was too badly worn, so I decided to 3D print another one from scratch. Here you can see newly designed one item. I will also 3D print this protective shroud. Yeah. Now that the parts are 3D printed, I will press one into each other. Material used here is PLA, famous material for 3D printing. It's got good mechanical properties, but unfortunately not UV resistant and unfortunately low melting point. In the future I will probably replace these parts with ASA, but for now this seems to be quite okay. Here I'm just slightly cleaning those lines from 3D print. Rubber mount is also 3D printed, anew. But unlike the other parts, this one is a rubber one and made with TPU, thermoplastic polyurethane. It's got excellent mechanical properties, but also chemically resistant material. I will slightly oil the stem before I put the rubber damper on it. The lithium grease here is not used mostly for lubricating, but for preventing moisture penetration on top of the damper. This plastic shroud is also 3D printed. It looks much better than the original, largely damaged one. Now that the upper part is done, we can continue with the lower part, the cylinder, again inserting the rubber mount. Then filling up with oil. And tightening all up. And that's it. Damper itself is finished. What's left is to mount it on the motorcycle. Yes, a lot of work still needs to be done here, including the nicer stainless steel bolts, of course, but no. And that's it. Thank you all for watching, and bye.